Your good buddy completing the square makes an appearance now, and he's really, really super handy,
He is.
especially when you want to get into vertex form.
He can be hard to get along with sometimes. He can make your life a little difficult, but you just have to know how to deal with him, and then everything's fine.
Yeah.
So let's talk about it. Let's do completing the square.
Let's deal with it. And I like to refer to completing the square as one of my good German buddies that I used to teach with way back in the day, Dr. Hoffen squared. Because ultimately what you're going to end up doing is taking Hoff and squaring it. So one of the things that helps the kids is the German reference part.
I see.
Hoffen
So
squared.
what you need to do is realize that by completing the square, we're trying to come up with something to stick in this blank so that we can factor this into the same thing twice, which is going to let us put a squared, and then we're going to end up with stuff on the outside as well. So we're trying to figure out what can I put here so that it factors evenly, and that's where Professor Hoffen square comes in.
Dr. Hoffen squared.
You always take this number 14, the number in front of x, you take 14 and you half it,
Hoff it.
and then you square it.
Hoffen squared.
So what we would put here is a plus 49. Now, am I just allowed to add stuff randomly to equations? Is
I'm
that
pretty
cool?
sure we have to follow rule number 72 of Algebra 1.
Which is that if I add something to one side of the equation, I need to also subtract it from that same side. Like
Yes.
somehow I have to keep it balanced. And so I can't just add 49, I also need to subtract 49. So we're going to stick that out here. Okay, I added 49, but I also subtracted 49. Together, those are 0, so I didn't
Nothing's
break the
different,
laws
nothing's
of
different.
math.
And this is mistake number 4,372. It can show up quite frequently if you're not careful.
Right. So if I wanted to factor x squared plus 14x plus 49, I would have to say, well, what multiplies together to get 49 that adds to give me 14?
I would say 7.
7 and 7, right?
Yeah.
So that's how we're allowed to put it as one parentheses with the squared, because we're saying that this top part factors into x plus 7 times x plus 7, which is x plus 7 squared.
You might notice that 7 is also what we got half of.
Right, this number right here, this 7, should always end up being that 7 over there, which will save you some work if you remember that. We also need to come over here and figure out what 51 minus 49 is.
I know that one.
Yeah.
73.
Plus 2.
Okay, that was my second guess.
Yeah, so we've completed the square. Our function in vertex form is in parentheses x plus 7 squared plus 2. And then we can describe the graph of that function because this is a graph that we've shifted
7 units to the left and 2 units up. Pick the pen up, Mrs. Stevenson. Yikes.
Okay, thanks. Yes. Shift left 7, shift up 2. So let's
Hey, by the way, let's just for kicks and giggles, the axis of symmetry on this one, could we identify that?
I believe that would be the x value of the vertex. So what is the vertex of this? We have to take the opposite of what's inside the parentheses, and we don't take the opposite of what's outside. So that means x would equal -7.
That's just pretty cool.
That is pretty cool. Are we done with this part?
Yeah, let's do the next one.
Okay, so obviously we can get more complicated with completing the square. It can't always be that simple.
If only.
What if we have a 2 here in front of our x squared? That's not going to work out. What we need to do is we need to say, okay,
Well, here's what we need to do. Dr. Hoffen squared is single.
Dr. Hoffen squared is single.
He only shows up around single folks. He is
Single x squared.
single x squared.
Not double x
He
squareds.
is not one to fly more than with just one x squared. So
That's good.
yeah, so whatever is in front of the x squared has to be factored out so that we only have a single for Dr. Hoffen squared.
What we're going to do is we're going to factor it out of these two terms that have x's, not the -19, which is convenient since -19 is not even. So if I factor out that 2, I get x squared plus 4x, and then I'm going to leave my blank because that's where completing the square is going to happen. And then the -19 is out here. And we're also going to have something that ends up there, just like in the last problem.
Rule number 75. Got to add and subtract at the same time on one side of an equation.
Okay, so we need to figure out what to put in here. We do that using this number in front of x. We do the Hoffen squared.
Hoffen, yep. We're going to take Hoff,
Take Hoff,
square it.
and square it, which gives us 4. So if I add 4, we need to realize that what are we really adding if we add 4?
2 times 4.
2 times 4, which is 8. So
Last
out
check.
here, we need to subtract 8.
Brilliant.
Okay? And that's because this is not really a 4 that we just added because we stuck it in the parentheses. We have to do 2 times 4 and get that 8. We really added 8, so we're subtracting 8. That's like the biggest hang up with these kind of
It's
complete
a mistake that is easy to make until you kind of get comfortable with it.
So easy. So 2 times, we can factor this x squared plus 4x plus 4 into x plus 2 squared. Negative 19 minus 8 is minus
27.
27.
Got that one right. I'm
Yeah.
on that.
So-
Hey, and there we are in vertex form. Now, I prefer vertex form myself because when I look at a vertex form of a quadratic equation, I know exactly where I'm at.
Exactly.
It's difficult to see exactly what my graph is going to be doing when it's just in that general x squared plus x minus a number form. So if we're really wanting to dig into a quadratic equation and check it out, always take the time to complete the square. Nice dig. Or you could be like volleyball dig.
Oh, okay. Yeah.
So anyway, but it always gives you an opportunity to see exactly where you need to go.
So we would shift left 2, down
Going down,
27, and then that 2 in the front, that's a vertical stretch of 2.
vertical stretch.
The way we do these problems, we are not really going to have to deal with horizontal stretches and shrinks because we want the 2 to be on the outside. We
That
just
is correct.
completed the square. So, vertical stretch of 2.
Fabulous.